We're looking at examples for position, velocity, and acceleration equations when it comes to calculus. What we're going to first look at here is we have a position function given here for all values where x is bigger than 0. That is a position in meters of some particle along a number line. The first thing it's asking for us to do is find the velocity and acceleration functions. Velocity is always just the derivative of position. So all I'm going to do is take the derivative of that first guy. So I bring the 4 down in front and get 4 over 12. That can reduce to be 1 over 3. My exponent is now x to the third. I'm going to bring the 3 out in front and get negative 3 halves x squared. Make sure you see that is a negative, a minus sign there. This will be then minus 4x, and then the negative 4 just disappears. Now, to find the acceleration function, acceleration is the derivative of velocity, or the second derivative of position. So I'm going to take the derivative of this velocity function we just did. 3 over 3 just becomes 1, so it'll just be 1x squared. I'll bring the 2 in front. The 2's will cancel out, so I'll have negative 3 and then x. This will become a minus 4 at the end. So that's just straightforward doing derivatives. Okay, what is the instantaneous acceleration? Instantaneous just means I need to plug in. So I'm going to plug in into the acceleration equation these times that they want. They want to know a of 0. And they want to know a of 2. So if I plug in 0, I'm going to get 0 squared minus 0 minus 4. So this is negative 4. My unit, because it's acceleration, we said it's in meters, so it would be like meters per second squared. They might have told you hours, and it'd be meters per hour squared, but meters per second is pretty much the norm. All right, when I plug in 2 in, 2 squared is 4, minus 3 times 2 is 6, so 4 minus 6 is negative 2. Minus 4 more is negative 6, so negative 6 meters per second squared. Okay, for part C, what is the average acceleration? When I say average acceleration, that means I always need to say, well, first of all, anytime I say average, I want to look one step above what I'm looking for. What I mean by that is what, when I take a derivative, would give you acceleration. Well, that's velocity. Velocity is one step above acceleration. Position would be one step above velocity. So what this means is I need to look at the change in velocity over the change in time. Okay? Change in time is easy to see because it gives you our 2 times. So 2 minus 0. Because I'm doing velocity, all I'm going to do is I'm going to use the same idea, but look at velocity at each of those times. So v of 2 minus v of 0 over 2 minus 0. And all I'm going to do is I'm going to plug in 2 into my velocity equation that I found in part A. When I plug those in, the first number, when I plug in v of 2, I get negative 34 over 3. When I plug in 0, everything just cancels, everything is just 0. And over the bottom, still 2 minus 0. So it's just negative 34 over 3 over 2. That can simplify to be negative 34 over 6, which can simplify further to be negative 17 over 3. I would leave it as a fraction. If it came as a decimal, it'd be like negative 5.6 repeating. My unit here is acceleration again, so this is still meters per second squared as my unit. Okay, when is the particle not accelerating? Well, if it's not accelerating, that means that the acceleration must equal 0. So all I'm going to do is set that equation for acceleration, x squared minus 3x minus 4 equal 0. Well, to do that, I need to get this into a factored form. So to factor that, that's the same as being x minus 4 times x plus 1. Now I have 2 factors equaling 0. That means each one of them equals 0. So x minus 4 equals 0 and x plus 1 equals 0. So my times are x equals 4 seconds and x equals negative 1 seconds. But something to keep in mind. Take a look. What was our original domain? We only wanted time being positive. So this x equals negative 1, we don't even look at it. We just completely ignore it. So the only time when it's not accelerating is when x equals 4. All right, the last part, the position of the particle when it is not accelerating. So we're looking for position, so that means I should look at my original function, my position function, and when was it not accelerating was just when time equaled 4. So I'm just going to plug in 4 into that original equation. And when I do that, I should just get an answer when I plug it in, negative 140 over 3, because it's position. What was I looking for? My position was in meters, so my unit should just be meters. And this would be, it would have been what, negative 46.6 repeating if you did it in terms of a decimal, but I would leave it just as a fraction. All right, here is another example. I would suggest pausing the video and giving this one a try with this position function and see if you can answer the 5 questions that we need. All right, let's take a look and see how you did. In the first part, what is the position when time equals 4? Well, that literally means, well, my position function, I'm just going to plug in 4 into that function. And just plugging that into a calculator, I should get negative 38 over 3, or I could have also been written in a decimal form as negative 12.6 repeating. And again, if this is position, we're going to say position right now is just in meters, so we're going to say meters as our unit. What are the velocity and acceleration equations? Well, velocity, again, is just the derivative of position. So when I take this derivative, I should get x cubed minus 5x squared plus 4x, and then that guy just goes away. The acceleration function is the derivative of velocity, so v prime of x. So when I take that derivative, I get 3x squared minus 10x plus 4. All right? Excuse me. When is the particle not moving? Well, moving deals with velocity. Velocity then would have to be 0. So I'm just going to set the velocity function equal to 0. So x cubed minus 5x squared plus 4x equals 0. When I factor that, I can factor out a GCF of x, which leaves x squared minus 5x plus 4. I can then factor that, so x times x minus 4 and x minus 1. This whole thing has to equal 0. So when I do that, that means each of the factors equals 0. Don't forget the x out in front. So x can equal 0, 1, and 4. Those are the times in seconds when it's not moving. And again, check with your domain. Does that work? Yes, it works fine with your domain. Nothing that needs to be canceled out. Okay, part D. What is the acceleration at x equals 4 and x equals 8? So I'm just going to plug in for a of 4, what it will equal when I plug it in, and a of 8 when I plug that in into my acceleration function. When I plug into a of 4, I should get an answer of 12, and its acceleration, so we'll say meters per second squared. And when I plug in 8 into the acceleration function, I should get a pretty big number, 116 meters per second squared. So accelerating pretty darn fast. All right, and the last part, what is the average acceleration and the average velocity? So we're going to look at acceleration average, and we're going to look, I'll write this one over here, at the velocity average as well. Okay, acceleration, the average acceleration, that means we again look up, change in velocity over change in time. My change in time here is going to be from 8 to 4, or 4 to 8 I mean, so that means I should look at velocity of 8 minus velocity at 4. Okay, I'll plug those in, well, excuse me. So when I plug in v of 8, I should get 224. When I plug in v of 4, I should get, well, I should get 0. Excuse me. And then over 8 minus 4. So this is 224 divided by 4, and so that gives me an answer of 56, and its velocity, or I'm sorry, its acceleration, so it's meters per second squared. Remember, always go back to what we started with, average acceleration. Okay, average velocity means change in position over change in time. So again, my change in time is from 8 to 4. That means I'm going to look at the position function at 8 and the position function at 4. So when I plug in f of 8, I should get, ends up being 890 over 3. And I plug in f of 4, well, I did that in part 1. That's negative 38 over 3, well, minus negative 38 over 3. So again, that'll mean plus a positive here. All that divided by 8 minus 4, which is 4. So when I simplify that, I should get my numerator as 928 divided by 3. My denominator is 4. So that's the same as 928 over 12, which can simplify even more to be 232 over 3. This is average velocity, so this should be meters per second. And again, if this was in decimal form, that could also mean the same as, it would be 77.3 repeating meters per second as well. So a couple different ways that you could have written that, 77.3 or 232 over 3.